Welcome. So in this lesson, what we're going to be going through is divisibility and prime factorization. Our learning intentions to be able to find the prime factor of a number, to understand how the lowest common multiple and highest common factor of two numbers can be found using their prime factor form, and finally to be able to use the divisibility tests for single digit factors other than 7. Okay, the first thing we're going to do here is a bit of prime factorization. The first question we have says express 24 in prime factor form. Okay, so there's more than one way of doing this. So the first thing that I want you to do is just divide this up into two sections for me. Divide it up into two sections. We're going to be showing you that we can find the prime factor form in two different ways. And in fact, there's more than two different ways to do this, but let me just show you two of them. Okay, so if I start with 24, what can I break 24 down into? Well, 24 breaks down into 12 and 2. 12 times 2 is 24. And what we're going to do is we're just going to pause here, and I'm actually going to circle this 2. And the reason why I'm going to do that is because it's a prime. So I'm circling my primes. Now 12 isn't a prime, so 12 isn't a prime, so I'm going to break it down some more. What if I broke it down into 3 and 4? Well, here I would pause again, and I would say 3 is a prime, so I'll circle that one, but 4 isn't, so we're going to continue on with 4 here. 4 can be broken down into 2 and 2, and both of those are primes, so we're going to circle those. Now what we're going to do is we're going to list out all the primes that we have. So we have 2 times 2 times 2. There are 3 2's. And then I have this 3, so times 3. Now we learned about powers in our last lesson. So instead of writing 2 times 2 times 2, we can write this as 2 raised to the 3. And then we have this times 3 as well. And this is my prime factor form. That right there. So let me put a box around it. That is the prime factor form. Now, as I said before, there's different ways you could break up 24. So let's break it up in a different way. So if I had 24, I could break it down into 8 and 3. Now 3 is a prime, so I'm going to circle it. But 8 isn't, so I'm going to have to break down 8. I can break 8 down into 4 and 2. 2 is a prime, so I'm going to circle that one. And now I'm left with 4. 4 is 2 times 2, and both of those are prime, so I'm going to circle those. And now I can just count them up again. So here I have 1, 2, 3 2's, 2 times 2 times 2, and then I have a 3 here. So that's the same as 2 cubed times 3. And as you can see, they're the same. So it doesn't matter how you break them up, as long as you do it correctly, you'll arrive at the same prime factor form. And if you were to grab your calculator and you were to go 2 times 2 times 2 times 3, what you would find out is that that is equal to 24. This is equal to 24. And that's the whole point of this, that it's just a different way of expressing that 24. 2 times 2 is 4, times 2 is 8, 8 3s are 24. That's what we're doing here. All right, let's go on to our next one now. You might like to pause the video and give it a go for yourself. So we're dealing with 60 here. 60 can be broken down into 6 and 10. 6 can be broken down into 2 and 3. 10 can be broken down into 5 and 2. All of those are primes. So let's now circle all of those. 2 is a prime, 3 is a prime, 5 is a prime, 2 is a prime again. We're now going to write it in our prime factor form. So I have 2 times 2 times 3 times 5. That is 2 squared times 3 times 5. Remember, our prime factor form is equal to what we originally had, so that's going to be equal to 60, and that's the best way to write it, like that. 2 squared times 3 times 5. Let's move on to our next one, which is 540. And you might be thinking, how on earth are we going to break down this big one? But what we're going to do is we're going to say, hey, we could break this down into 54 and 10. Pretty easy. Then 10 can be broken down into 5 and 2. 54. Now, what does 54 break down into? Well, I can break it down into 6 and 9. 9 can then be broken down into 3 and 3. and then 6 can be broken down into 2 and 3. And as you can see there, I stopped every time I got to one of my primes. That's a prime, 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 that's a prime. Now I'm going to write my prime factor form. So it's 1, I have 2 2s, I have 1 2 3 3s, and I have 1 5. Now remember, this is going to be equal to 540. And a better way to write this would be 2 squared times 3 cubed times 5. That would be the best way to write it. And that's our prime factor form. That's equal to 540. Perfect. Let's now move on to our final one. And again, I want you to pause the video and I want you to see if you can do this one for yourself. Remember, the best way to learn is to try things for yourself. Okay, hopefully you've done it. Let's now go through it together. I have 140. I'll break that down into 14 and 10. 10 can be broken down into 5 and 2. 14 can be broken down into 7 and 2. All of those are primes. This is a prime, this is a prime, this is a prime, this is a prime. If I want to do it really quickly, I could say I have 2 2s, so that's 2 squared. I have 1 5, I have 1 7. That's my prime factor form. That is going to be equal to 140. And we're done. That's how we would do prime factorization. Now, the question is, how is this useful? How is this a useful skill? Well, it's useful when we're trying to find the LCM and HCF of numbers that maybe are a bit difficult to do it in our traditional way. Remember, in our previous lesson, we learned about how to find the LCM and HCF in the easy way. So when the numbers are kind of small and manageable, we can, just list them out and find them all. Maybe we can just think about it. But if we were given examples like this, find the LCM of 105 and 90, well, they're big. So what we're going to say is, well, to find my LCM and HCF, we're going to use prime factorization. So what I want you to do is let's just cut this in half. And on one side, we'll deal with 105. And then on the other side, we'll deal with 90. If I was to break down 90, so I'm just doing my prime factorization here. So 90 could be broken down into 9 and 10, then 5 and 2, and then 3 and 3. All of those are my primes, so I would circle them. This is going to be 2 times 3 times 3 times 5, or to say it another way, it is 2 times 3 squared times 5. If we were to deal with our other one now, so let me come over to my 105. If I have 105 and I want to break that down, what would that be? Well, it's going to be 5 and 21. 5 times 20 is 100, so 5 times 21 is 105. Now, 21 can be broken down into 7 and 3, and both of those are primes. Whoopsie daisy, whoopsie daisy. So let me now circle those. So now I'm going to get 3 times 7 times 5. And that can't be simplified. And I can't put those as powers because I don't have any doubles. All right, that's the easy part. That's the part you should be able to do. And you'll be able to do this next part as well. But this next part requires a little bit of thinking. We're going to find the LCM. Let's read this definition now. This definition is a little bit wordy, but once we see how it works in action, it will make more sense. For the LCM, include all different primes, raising the common primes to their highest power. Wow, what on earth does that mean? What we should do here is let's just write it out again. So let's just say I've got 105, and what I know is that breaks down into my prime factor of 3 times 7 times 5. And then I also have, and you know what, I might not write this 105. And then for my 90, let me just write it here. I have 2 times 3 times 3 times 5. So I've just written them down there. So I just took that and I wrote it there. I took that and I wrote it there. Nothing too tricky. All right. What we're going to do now is we're going to take all the different primes, raising the common primes to the highest power. Okay. So what we're going to do now is we're going to take all the different primes. Well, here I have a 2. So I'm going to go 2. Then I'm going to multiply it by the next number prime I have. Well, that's 3. And as you can see, 3 is a common prime. And what we're told is that we should take the highest power. So that means I'm going to take these two here. So it's going to be 3 times 3. The next prime I have is 5. Now I have 1 5 here and 1 5 here, so they're common, but you take the highest power. Well, in this case, the highest power is just 1, so it's just 1 5, so I just times it by 5. Then the next number I have is 7, and there's only one 7 there, so I times it by 7. When you multiply all those together, what you're going to end up with is 630, and that is going to be your LCM. Now we're going to do another example of that soon, so don't freak out too much if you're like, what on earth just happened here? Let me go through it again, but we'll go through another example as well. So what you have to make sure is that you take all the different primes. So for instance, 2, I put my 2 here. I had 3. Now when you have common primes, you have to take the one with the most. So this had 2, 1, 2 here, so I had to put 2 3s here. Then I had 5, so I put a 5 there. And then I had 7, so I put a 7 there. And then I multiplied them all together, and that's my LCM, 630. Let's now do the HCF. All right, so for the HCF, it says, for the HCF, include only common primes raised to the smallest power. This one's a bit simpler. Let me show you how you would approach this one. So again, what we're going to do is we're just going to write down our prime factor form. So 3 times 7 times 5. And then 2 times 3 times 3 times 5. Now, unlike our LCM, where we had to take all the different primes, here we're only concentrating on the common primes. So that means, let's get our highlighter, and let's say I have a 3 here, and I have a 3 here. Fantastic. And I also have a 5 here, and a 5 here. So that means, what it's going to be is simply 3 times 5, which is equal to 15. And that's all we do to find our answer. And can I just do that in red so that my colors are all consistent? 3 times 5 is equal to 15. And that's how you do it. Nice and easy. So normally people get kind of stuck on the LCM because it's a little different. With the HCF, you just find the common ones, you multiply them, and you're done. Okay, would you like to pause the video and try this next one for yourself? So we're going to use those same techniques. Pause the video and see how you go. All right, I'm going to go through it now. Let's do this. I've got 63 over here. I've got 27 over here. Let's find our prime factors, prime factor form. 27, let's break that down into 9 and 3. Then 3 I can break down into 3 and 3. Everything there is now a prime, so let's circle all of them. So it's going to be 3 times 3 times 3, which is 3 cubed. And then for 63, what can I break 63 down into? Well, what about 9 and 7? 9 and 7. 7 is a prime. The 9 is 3 and 3. Now all of those are primes. So I've got 7, 3, and 3. So it's 3 times 3 times 7, 3 squared times 7. So those are my prime factor forms. Now I'm just going to come over here and I'm just going to rewrite this. So I'm going to take this and I'm just going to write it out again. And then I'm going to take this one and I'm going to write it out again. Okay, now remember for your LCM, you're going to take all the different primes, and when you have them common, you take the one with the higher number. So for instance, I have 3. Here I have 2 3s. Here I have 3 3s. So that means I take the 3s, the 3 3s, because I have more of them. So I take those ones. Just like over here, if I was to go back here for a second, here I had 1 3, here I had 2 3s, and I added 2 3s here. Hopefully that makes sense. Now I have to take all the different primes. I also have 7. Now this isn't a common prime, so I just have to put 7 over here as well. So now I times these all together, and when I do that, I'm going to end up with 189. That's going to be my LCM. Let's now go through HCF. So for our HCF, what we do is I'm just going to write down this first, 3 times 3 times 3, then 3 times 3 times 7. Now what we do is we say, what do they have in common? Here I have 2 3s, Here I have 2 3s. That's what they share in common. They both have 2 3s. So that means to find my HCF, I go 3 times 3, which is 9. That's going to be my highest common factor. And that's how we approach it. Hopefully that makes sense on how we approach those things. I think I might pause the video here and make a part 2 for the next part, which is all about divisibility tests, because there's a lot of information right here already about prime factorization that I hope you've all understood. If anything here is unclear, make sure you find me and we can talk about it some more and go through some more examples together. All right, with that, I will see you in part 2 of this lesson.